Hi all and welcome. Today we'll learn how to build a densimeter. A densimeter is an instrument that we can use to measure densities of fluids. We only need few things, two glass beakers and two different fluids. The first beaker is filled with distilled water, and naturally its density is 1.0 grams per cc. And the second beaker is filled with the solution made up of water and salt, NaCl. I decided to use a density of 1.2 grams per cc. Don't use a higher solution, otherwise your densimeter will not be built. We also need a test tube, but a large test tube, not a narrow one. Iron filings or iron powder, a plastic dropper, a permanent marker, scissors, and a folded piece of paper. Okay? Let's start. The first thing we have to do is to cut the upper part of our dropper. Why? Because through this hole we'll have to put the iron filing. So it's too narrow. Cutting the top of our instrument with the scissors, the hole becomes larger. Perfect. And the operation will be faster. Second thing, take your folded piece of paper, open it, and put on it your iron filing. Close the piece of paper, and in this way, carefully, you can put the iron powder inside the dropper. You have to decide the correct amount of iron filing. You must put inside the correct quantity, because otherwise the dropper touches the bottom of your first density beaker, and it will not work properly. Okay? I decided and I established the correct amount of iron powder before, so I prepared this densimeter. This is the correct quantity of iron filing. Now put your instrument inside the first solution and you'll see that it sinks, but it doesn't touch the bottom of the beaker. In fact, it moves if I touch it. Okay? Perfect. Now take note of the floating point with your fingers, and with your permanent marker draw a line on it. Now the densimeter must not be wet. Put the clean densimeter in the second solution. It will sink less than before, because the density of the second beaker is higher than the density of the first one. In fact, the situation is this. Take note with your fingers of the position of the floating point and put a line in this position. Perfect. The thing you have to do now is to divide this interval into two parts with your marker, okay, with your permanent marker. So you can use this instrument from now. If you are able to do it, I can't do it. You can write numbers on the densimeter: 1.1, 1.0, 1.1, 1.2. Our second activity can be measure the density of a new solution. We can create a mix of the first two solutions. Let's put a large quantity of distilled water and a little quantity of solution of the second solution. Okay, so the density will be higher than 1.0 but lower than 1.2, and because of the different quantities of the fluid, of the two fluids, the density will be closer to 1.0 than 1.2. Take your instrument, put it inside the test tube, and in fact it's lower than 1.1. It's between 1.0 and 1.1. Let's give a look. Let's try to avoid the parallaxis error, lifting the test tube, and it appears to be about 1.05. I think it's more 1.06 density. Naturally, I know that this kind of operation is not correct. We have the decimal numbers after the comma, so it's impossible, but it's only an example. The instrument is rudimental. Perfect. Okay, so it works. We can also do another thing. Take the instrument, clean it, and do this. Put another quantity of the second solution in your test tube. Now the density will be near to 1.2, nearer to 1.2 than 1.0, because the quantity of this solution in the test tube is higher than the quantity of distilled water. And in fact, if we put our densimeter inside the test tube, the density is higher than 1.1, and we can see it. It's about 1.12, okay, higher than the previous solution, so it works very well. Okay, perfect, it works. I'm a very good teacher. Bye, see you next time.